Good morning, everyone. Here I'm Valentin Kozlov, and I'm grateful to the organizers for giving us the opportunity to talk about the quality-based approach for research software and services, which we're developing within our EOSC Synergy project. So let's make it full screen. A few words about myself. I'm actually trained as a physicist, worked a number of years in physics, and since 2018, I work at Steinbuch Center for Computing at Karlsruhe Institute of Technology and participate in various European projects. Well, maybe just to ensure the better quality, I stopped sharing the cam, but you saw me. Then here is the outline of the talk. We work in European projects, so our community is very much related to what is called European Open Science Cloud, and I will say a few words about it. The current project under EOSC umbrella is called EOSC Synergy, and I will also say a few words about its use cases and what this project is about. And then the main part of the talk is about software and service quality assurance approach, which we are taking, and which includes baseline criteria documents for both software and services, and then the corresponding SQS, so software quality assurance as a service platform with its components, and then make a little demo of this platform. European Open Science Cloud. This is a European Commission initiative to provide researchers, companies, and basically all citizens with a federated and open multidisciplinary environment for publishing, finding, and reuse of data, software, and services. So it's a kind of hub to share the scientific data, software, and services. And of course, for this sharing, it is of high importance to ensure that what is shared is and what is available for the community has good quality. And when we talk about quality, for instance, for data, like raw material produced and consumed via software, we often talk about the fairness of data. Then software, like code in any format, of course, software quality assurance, and services like long-running instances of the code, service quality assurance. And that's what we want to foster in our project, to bring this quality to all these EOSC assets in a consistent and coherent way. EOSC Synergy project, as it is European Commission funded project, which means it runs for about 3 years, started in 2019 and ended in October this year. It aims to expand EOSC by leveraging investments, resources of national digital infrastructures and existing experiences and know-how from national services towards European community, so towards EOSC. And also one of the goals, as I said, to foster EOSC with the software and service quality. We have a number of thematic use cases. Every one of them has its research software and service, and they come from different domains in research, including astrophysics, biomedicine, Earth observation, and environment. And within the project, we provide to those use cases federated AI access to the, again, federated resources, mainly based on the OpenStack. Then the software quality as a service, which I will talk most of the talk. And fair assessment of the repositories, and also there is a learning platform to provide learning material for the users of, again, the research communities, and this platform is based on Moodle. Then, just to present the use cases which come from, for instance, Earth observation. This is, for instance, Valentin water monitoring cloud platform, or SAPS, surface energy balance automated processing service, which can be used, for instance, in agriculture, GCore, and a number of other projects in biomedicine, like Scipion, Open, eBench, LAGO. This is from astrophysics and measuring cosmic, it's an observatory for cosmic rays. Also in the environmental science, we have 4 projects, and for instance, one of them is Ozone Assessment Service, O3S, which we are developing at KIT. Then the process to foster this quality is outlined here on this slide. We have the real use cases, the real research software and services coming from different communities. Based on the experience, on our experience from previous projects, we develop quality baselines with quality criteria so that against which the software can be tested. So these are the best practices and guidance for the research software and services, what they have to do to ensure this the quality of their software. And okay, this is a guideline, and it's these are live documents. But then we go next step to develop the platform, which brings the automation of testing against this quality criteria, and this is SQS platform. Then, depending on how many of this quality criteria the software satisfies, how many of these quality criteria, we can also issue quality badges like digital stamps. This software qualified against those and those criteria, so that's the stamp, ensuring that finally we get trusted integrated services for the EOSC community or ecosystem. Those documents which I mentioned, there are two of them. One is for the software quality, so it's called a set of common software quality assurance baseline criteria for research projects. This is a live document hosted at GitHub, and basically everyone can contribute via GitHub issues. It is sort of regularly, there is a versioning approach. It means that there are different versions and which are then converted into HTML and PDF formats and published at the digital Valentin repository with DOI number. Yeah, here on the right, you can see the document. I don't know if you see my mouse, but so in the right bottom corner, then this is the example of those quality criteria like code accessibility, licensing, code workflow, code style, code metadata, unit testing, and so on. Here is then the example of what is described in the document, for instance, for the unit testing, that there are criteria like the minimum acceptable code coverage threshold should be 70%, that the unit testing coverage must be checked on change basis. There is a new version of the code. Must be automatic testing for the test coverage. And this has to be automated. Then another document describes similar quality baseline criteria for services, and this is also a live document and in similar way hosted at GitHub so that everyone can contribute. And that then again on the bottom right corner you find the examples, what are the criteria then described in the document, like integration testing, API testing, functional testing, and security, and so on. So these are the documents which help, again, to improve the quality of the developed research services and software. But in the next step, there is the SQS platform to facilitate the assessment of these criteria. Two main parts of the platform are to build pipeline as a service that that's basically CI/CD pipeline for your software. So you compose the pipeline and you run the pipeline and get results. And quality assessment and awarding, where you then able to test also your repository against those quality criteria, and depending on how many of these quality criteria are available for testing of how many quality criteria you satisfy, then corresponding badge is issued. A bit more details about the platform and its architecture. The core system, so what you see at the bottom, Jenkins pipeline library, which means that yes, we're using Jenkins CI/CD system, and above that system there is a Jenkins pipeline library which facilitates description of those quality checks. It is a standalone product in itself, so you can just use the library and implement that include that in your Jenkins file and profit from simply a description of the pipelines. And as a developer or computational scientist, then you can immediately step in and use it. For broader community and for easier build up of the pipelines and assessment of the repositories, there is a web interface. And well, between the web interface and the JEPL, the library, there is an API server, which also allows programmatic access to the functionality of the library, and as well communicates to the badger service for issuing the badges. So the Jenkins pipeline library again implements those baseline quality criteria described in the document, and then instead of dealing with the Jenkins file and describing every stage, one uses YAML config file where those stages are described in a kind of more intuitive way. Currently implemented checks against for style checking, unit testing, functional testing, and if there is a documentation and if it builds correctly. If you use the library directly, then one has to describe so-called config, or the config file where the quality verification stages are described. Then behind the scene for the Jenkins system, or the checks themselves and the tests, they run in a Docker container or in a set of containers. So Docker Compose is used. Then one has to describe a corresponding Docker Compose YAML and Jenkins file that the Jenkins system recognizes that, okay, this repository is something what it has to watch. But basically, in the minimum implementation, you just include the library and the standard code. I mean, the few lines which can be unique for different repositories. The current implementation is 2.1, and the slides will be available. So the JEPL link then goes to the GitHub, and there you can find more details and also the link to the documentation for the library. That's just an example how the pipeline can look like. It's those stages in Jenkins are built dynamically based on the config YAML. And then what we see in this particular example, that there is a style check, there is a coverage for the unit tests, there are functional tests, there is a security check, and once all these tests are passed successfully, we can push the Docker image to the Docker Hub registry, for instance, and then also test the documentation of the repository, or for the software hosted in the corresponding repository. Clearly, all the components of the platform use the library itself, and also thematic services implement the functionality of this platform in their pipelines. And thematic services not always mean, of course, one repository, but there can be a set of repositories for every service. Then the API is SQS API is based on the Open API 3 specification. It follows API first strategy, which means that we first describe the API specification, like in the swagger.yaml file, and then we used code generators to generate the kind of code template for the corresponding software. There is an API server, the Open API specification hosted in a separate directory or repository as a set of YAML files, and one can also access the API documentation. Within the project, there are different endpoints for development stage and, of course, the production one. The current service is deployed in the AGI Cloud Compute Federation. AGI stands for European Grid Infrastructure. The platform is the API can be deployed on top of a Kubernetes cluster, and for instance, by the means of infrastructure manager. And for the authentication, we use, again, AGI check-in. Then the web graphical user interface, as I said, aims to bring a friendly way how to compose the pipelines and access quality. You first describe what, if you need, what you want to test just, and how many repositories have to be included in the test, then which Docker container, Docker image you want to use. Do you want to pull the Docker image for your testing, so where you will test on the Jenkins side? Do you want to pull it from the Docker Hub, or will you build dynamically from a Docker file which is hosted in certain repository? Then you describe which software quality criteria you want to include in this testing. And at the end, you get a set of files which you can include in your research software repository. You may directly from the web interface also do a pull request to the repository, and also it is possible to execute the pipeline as well. So that's the pipeline as a service, and the second is the validation with badges. But that's currently work in progress, and I will say a few words more a bit later. Now, if everything goes right, we can go to the platform. We sign in with the AGI check-in, which is a federated authentication and authorization. So, for instance, I think also Humboldt University of Berlin should be. Yeah, Humboldt University. So there is a really broad set of universities who can use this service. I'm just using, for instance, also not only university access is available, but you can log in like with Jorge account if you like, or do it via the institutional access. Oh, yeah. Seems to be a bit slow. Great, except that I have to be redirected. Yeah. Okay, so we have this pipeline as a service, and we can start building. For the purpose of this demo, I just created this is a real software we're using in the project, and I just created a branch where I deleted the existing pipeline, and now sort of will recreate it. Yeah, I don't need any further repositories, so we can skip this step, but we will use service name, okay, processing, that's more or less the container name, and we will pull existing image for executing the tests. And I should not take some typing. Otherwise it will not work. Okay, edit, next. we select the criteria we want to test, and here there is a different tools. If a certain tool for different languages is not included, that you can always use commands and describe which command you want. But in that particular case, I have already docs tool set with the corresponding configuration. So for instance, the style check happens in the PEP8. It's a Python project, PEP8 environment. So we add that, and for the same stage, or for checking the same criteria, there can be several tools used, and that allows you to select different tools. But in this, again, in this demo, it's only one tool which is needed. Then let's do functional testing in the same container. And it's again docs tool, and what is here is in fact cobertura. And let's add also security. Same container. So one can use directly Bandit, but again, in the case of docs, we can use the docs tool with the corresponding environment. Okay, and basically it. And something went wrong. That did not supposed to happen. So I may know, because clearly I was a bit too fast. Come on. Create pipeline. Services. Wait, container. That's it. I must. Yeah, that was a bit, sorry, quite. Of course, we use external repository, so I have to give a repository which I want to add, to which I want to add my pipeline. It cannot add just in vacuum. It has to know where to add the pipeline, and that's the repository URL and the branch which I want to use. And this is exactly this branch which I was showing here. And yeah, well, that has to be added. It has to be added. And sorry for that. Yeah, now it's added. The rest, the image is there. The quality criteria are there. So now, yeah. That does not supposed to happen. It was tested yesterday and everything worked. Let's check. External repository is there. Processing. Sorry, that let me see. This is correct. This is fully added. This is correct and fully added. Then let me recreate these guys, at least one. Okay. Maybe one more. Yeah. The criteria. Well, that's very pity. But unfortunately, I mean, sorry guys, I was testing that 5 times yesterday. Everything worked perfectly, and I'm not sure what's wrong now because all looks Integra Data Cloud. Well, let's just give me one more try because the Docker image I specified is not correct. I'm anyway about data cloud images 5.6.
I just want to remind you about time.
Okay.
Maybe
Still.
3 more minutes.
Yeah.
Maximum 5.
Poof. Well, that unfortunately was not successful, which I'm really sorry, disappointed because I mean it works. I know because that was like less than 12 hours ago tested. Yeah, what I said as well, we have infrastructure manager and what we target is to deploy this whole platform that it is possible to deploy it on premises. And for that, we have infrastructure manager to deploy basically in any cloud, or like federated cloud, but also just an OpenStack cloud or Amazon Web Services or Google Cloud. One can deploy Kubernetes, and on top of this existing Kubernetes, you can deploy the platform. Then for the quality badges issuing, we have, again, some technology scouting, and there is a white paper published on how these quality badges can be issued. And what we had chosen is the open badges specification and badger system. And yeah, depending on how many quality criteria are satisfied, you can have either bronze or silver or gold badge. And then concerning the data, we also assessed what is available for fairness of the data and what tools can be used. And this is now currently being implemented into the platform as well. So with that, in the project, yes, we want to foster the software quality and service quality for the research software. And this is based on those quality baselines and the criteria, and the corresponding platform with its components is being developed and brought to the users. Here is the number of links which you can click on and get more information. And with that, thank you for your attention.